Welcome back. In this lesson, we are exploring the first four characteristics that make science work. These characteristics ensure that scientific findings are reliable and can be trusted. They are like the quality control system for science. Let's start with reproducibility, which is one of the most important characteristics. Reproducibility is the foundation of scientific trust. Imagine if every time you did an experiment, you got different results. You wouldn't know which result was correct. But in science, if an experiment is done properly, other scientists should be able to repeat it and get the same results. This is how we verify that findings are real and not just accidents or mistakes. For example, if I measure the boiling point of water and get 100 degrees Celsius, and you do the same experiment and also get 100 degrees Celsius, and a scientist in another country does it and gets 100 degrees Celsius, then we can be confident that 100 degrees Celsius is the correct boiling point of water. If someone gets a different result, it tells us something might be wrong with their method or equipment, and we can investigate why. Reproducibility is crucial because it means that scientific findings are not dependent on one person or one laboratory. They are universal. Any competent scientist following the same procedure should get the same results. This is what makes science so powerful and trustworthy. Observation is where science begins before you can ask a question or test an idea. You have to observe something. You have to notice what is happening in the world around you. Good scientists are keen observers. They pay attention to details. They notice patterns. They ask themselves questions about what they see. For example, you might observe that plants always grow towards the window where light comes in. You might notice some objects float in water while others sink. You might see that sugar dissolves faster in hot water than in cold water. These observations lead to questions. Why do plants grow toward light? Why do some things float? Why does temperature affect dissolving? And these questions lead to investigations. So, observation is really the starting point of all scientific inquiry. Without careful observation, there would be no science. Scientists spend a lot of time just observing and noticing things. They keep detailed records of their observations. They look for patterns. They ask questions. This is how science begins. Empirical evidence is about facts, not opinions. In science, we don't say, I think the plant is big or I believe the water is hot. Instead, we measure. We use instruments. We gather concrete data. For example, instead of saying the plant looks big, we measure it with a ruler and say the plant is 15 centimeters tall. Instead of saying the water feels hot, we use a thermometer and say the water is 75 degrees Celsius. This is the difference between empirical evidence and opinion. Empirical evidence is based on measurement and observation. It is objective. That means it doesn't depend on what one person thinks or believes. Two different people measuring the same plant with the same ruler will get the same measurement. That is the power of empirical evidence. It is reliable and trustworthy. It removes personal bias. When science is based on empirical evidence, we can trust the findings because they are based on facts, not opinions. Precision is about consistency and detail. A precise measurement is one that you can repeat and get the same result. For example, if you measure the length of a pencil with a ruler marked in millimeters, you might get 19.2 centimeters. If you measure it again, you should get 19.2 centimeters again. That is precision. But if you just estimate the length by looking at it, you might say about 19 centimeters one time and about 20 centimeters another time. That is not precise. Precision is important because it allows us to compare results accurately. If one experiment gives a result of 25.3 degrees Celsius, another gives 25.4 degrees Celsius, we know they are very similar. But if one says about 25 degrees Celsius, another says about 26 degrees Celsius, we don't know if they are really different or just imprecisely measured. So precision matters for reliable science. When we use precise instruments and record measurements with appropriate detail, we get data we can trust and compare. Let's recap the first four characteristics of science. Reproducibility ensures that results are reliable and can be verified by other scientists. Observation is where science begins. That is careful watching of the natural world. Empirical evidence means we base science on facts and measurement, not opinions. And precision means our measurements are consistent and detailed. These four characteristics work together to ensure that science is reliable and trustworthy. When we combine reproducibility, observation, empirical evidence, and precision, we get data we can trust. In our next lesson, we will continue exploring the characteristics of science. We will look at accuracy, validity, consistency, and tentative nature of science. These characteristics help us understand how science evolves and improves over time. Don't miss it. Thank you for watching part 1 of the 14 characteristics of science. If you enjoyed this video, Please like and subscribe. Leave a comment telling us which characteristic you find most interesting. Do you think reproducibility is important? Have you noticed how observation is the foundation of science? We love to hear your thoughts. See you in the next video.